Welcome to next lesson. In this lesson, we'll focus on .loc or .loc. It is a powerful method for accessing and manipulating data in Pandas. .loc allows you to select rows and columns based on their labels, which makes it intuitive and versatile. Let's dive in using the Toyota sales and sales representative datasets. First, let us go to the details about what is .loc. .loc is a label-based indexer in Pandas. This means you can use row and column labels to access specific parts of a data frame. It also supports conditional filtering, which makes it very useful for analyzing data. Let's begin by loading the datasets we'll work with. I have already copied the code here. I need to fix the path. Let me say data/car_sales, then slash. Here also I have to specify that. Let me specify. Now let me run this. Let me review the data related to Toyota sales. In this case, I'm using head function to review the data. You can see first 5 records. Now you have labels for rows as well as columns. These are the column labels you can see here. The label for the first column is nothing but sale ID, then sale rep ID, sale date, so on and so forth. Even rows have labels. The label for first row is nothing but 0. The label for second row is nothing but 1, so on and so forth. The index values are nothing but labels for rows. With .loc, you can select specific rows and columns by their labels. Let's extract car model, sale date, and sale amount by using column labels. And also let's extract the first 5 rows from the dataset using row labels. For that, we should be able to come up with code like this. Let me say Toyota_selection, then equal to, then Toyota_data.loc or loc. Then in square brackets, we should be able to specify the row labels like this. So if I say 0:4, it will retrieve first 4 rows starting from first row. Let me run this and see whether we'll be able to get the first 5 rows here. Let me actually copy this. Let me paste and then let me run this. You can see first 5 rows. In case if I say 0:2, it will only give me the first 3 rows. You can see the outcome here. It is only displaying the first 3 rows. Now, if you wanted to get only 3 columns by using labels for these 3 rows, you should be able to specify the column names in the form of a list like this in a second argument. So here I should be able to say sale_date, then car_model. That will be second element in the list. So car_model. Then the third element is nothing but sale amount. You can specify as many columns as you want in this list to project data related to only those columns. Now let me run this. Then let me run this. You can see we are able to see only sale date, car model, and sale amount. In case if you wanted to display sale rep ID as well, you should be able to say sale_rep ID like this along with the other 3 columns. Now you should be able to see all the 4 columns here. Now in place of these 3 rows, if you wanted to get 10 rows, you have to change this to 9. So it will start all the way from first row in the data frame till 10th row. The index value of first row is nothing but 0. The index value of 10th row is nothing but 9. Now let me run this and then let me run this again. You can see the data here. It have 10 rows and 4 columns. This is how you should be able to use .loc to get the values from the data frame using both row labels as well as column labels. When it comes to .loc, one of the most powerful features is its ability to filter data based on conditions. Let's find all Toyota car models with sales greater than 30,000. If you look at the outcome here, all the sale amounts are above 20,000. I would like to get only those with sales greater than 30,000. For that, we should be able to come up with a logic like this. Let me say high_sales equal to Toyota data, then .loc. In square brackets, you should be able to specify the filter. The filter can go like this. Toyota_data, then sale amount. This is the column where we have the values related to the sales. Here we should be able to say greater than 30,000 to get only those sales where the sale amount is greater than 30,000. Now let me run this. Let me preview the data related to high sales. You can see the outcome. If you look at sale amount, you see all the sales are greater than 30,000. We have total 5,000 records in this data frame called as Toyota_data. Now with respect to high_sales, we only have 2,976 rows. So out of 5,000 sales, only 2,976 sales are greater than 30,000. When it comes to dot lock, you can further refine your selection by specifying the columns you wanted to include. For example, let's get the car model and sale amount columns for cars with sales above 30,000. I have copied the code which I have used earlier. Now let me change the name of this to high sales models. Now on top of filter, I should be able to specify the columns which I am interested in. Let me say sale rep ID. I want to get sale rep ID as well. Then car model, then sale date and also sale amount. Now let me run this. Let me make sure I format this for readability purpose. The first element in this square brackets is nothing but the filter condition where Toyota data sale amount is greater than 30,000. The second element is nothing but column names. Now I have already ran this. Let me copy this. Let me paste here. Let me run this. Now you can see the results here. For all 2,976 rows where sale amount is greater than 30,000, we are able to see only the 4 columns: sale rep ID, car model, sale date and sale amount. That being said, you can combine multiple conditions using dot lock. Let's find all sales where the sale amount is greater than 30,000 and also the car model is RAV4. The logic will be something like this. I'll be copying this, then pasting it here. Here I'll be adding one more condition. The condition is nothing but Toyota data, then car model double equal to RAV4. Here you need to ensure this condition is in circular brackets. And also this condition is in circular brackets. Here we are performing Boolean AND operation with the 2 conditions. Now let's run this. Then let's review the outcome here. You can see the data as per the expectations. We are only seeing the data related to RAV4 where sale amount is greater than 30,000. Out of 5,000 rows, we only have 519 such rows and we are only seeing data related to 4 columns by labels. You can also use dot lock to update specific rows or columns. In this case, when it comes to Toyota data, commission percentage have a lot of null values. Let's say we wanted to update commission percentage to 0 when it is null. Then the code will be like this. First, let's preview the data of Toyota data. You can see here a lot of commission percentages are null. First, let's try to filter for these records. For that, we should be able to say dot lock, then Toyota data, then commission percentage, then double equal to none. Let's run this. It haven't returned anything. I guess I have to use dot is null. Now you can see there are a lot of records where commission percentage is null. Out of 5,000, 1,274 rows have commission percentage as null. Now we wanted to set commission percentage in these records to 0. For that purpose, I should be able to specify the column name, which is nothing but commission underscore PCT. Then I wanted to set to 0. Let me say 0.0. Now let me run this. It have ran successfully. Now let me copy this, let me paste, let me run this. You see all the nulls or nans have converted to 0 here. So you can also use dot lock to update specific rows or columns as demonstrated. That being said, in this lesson we explored dot lock method for label based indexing in Pandas. You learned how to select specific rows and columns using labels, filter data based on conditions, update data and combine multiple conditions for advanced filtering. In the next lesson, we'll explore .ilock, which is used for position-based index. This complements .lock and gives you another powerful tool for working with your data in DataFrames. See you there.